All right, hey everybody. I was just going to walk you through the end of lesson 8 here because I'm gone today. So just a couple things real quick. We did the lab yesterday with the Domino's Shire, and we were trying to show the whole idea behind a chain reaction. But I want to talk about this really quick. So there's the two types of radioactive equations we're going to look at, or nuclear equations we're going to look at: fission and fusion. And the major difference between those two is fission is when you split an element into two different smaller elements, and fusion is when you combine elements together to form a new heavier one. So fusion, you're taking two things and putting them together and fusing them together into one thing, and fission, you're taking one thing and splitting it into two other things, right? Fusion actually produces way more energy than fission, but both of them produce a pretty large amount of money. Oh my gosh, large amount of energy. And what this graph is showing is that basically the size of the atom matters. So the smaller elements, which would be those ones on this side of the line here, so from 0 to maybe like 40-ish or 50-ish, those are going to be in fusion reactions. And the ones that are bigger than that, larger than that, are going to cause or be in fission reactions. And the reason why is because the smaller ones, it's easier to put those two nuclei together. So they're not quite as big, so we can squish them together easier. Fission, because you have such a big atom, it's easier to break it apart. Okay, so, and then just real quick about chain reactions. Chain reactions are just when you start one thing and then it hits and causes another reaction, which causes another reaction, and so on. So this is what happens in a fission reaction. We have a neutron that's fired into uranium in this case, and the uranium splits, and it also gives off new neutrons. So we start with the uranium, it splits into two parts and gives off two new neutrons. Those hit other atoms of uranium, and then they split and give off more neutrons, and that process just continues on. And the general shape is kind of like a triangle. Okay, and some of you set that up yesterday in the lab. But basically you start it and then it just continues on and it gets bigger and bigger and bigger. Okay? All right, so I wanted to look at this, and so we're going to go through and ask you to figure out these different reactions and what the missing element or particle is in these. Okay? And so this is fission, and fission is when you have one element and it changes or it gets split into two elements. Okay? So here's an example. We have uranium, gets hit by a neutron, and it gets split into two elements. We're going to try to figure out what this second element is. Okay? And we're going to use the idea of conservation of mass. We've done something similar to this before. Basically, the mass on the left side of the equation, or this side of the arrow, has to be the same as the right side. Okay? So if we look, sometimes it's helpful to put a little squiggly line here to kind of separate them. That's what I usually do. If we add up the masses on the top, we have 236 on the top here, okay, on the left side. So that means I got to get 236 on the right side, okay? And so if we look right now, we have 141 from the barium, and here we have 3 neutrons. So we have 3 neutrons, meaning I have 3 of the one mass. So I have 3 times 1, or 3 of the mass of the neutrons. So the total there is 144. All right? But I want to get to 236 total. Okay? So this missing element must have the difference between those two. So 236 minus 144 gives me 92. So the mass of this missing element is 92. Okay? We do kind of the same thing on the bottom. For protons, we have 92 protons here and 0 here, so there's a total of 92 protons on the left side, and on the right side we have 56 and 0. So I need to get more, right? So I'm going to do 92 minus 56, and I get 36 as my missing number of protons. So this is 36. And then if I look at the periodic table, element 36 is krypton. And so we've created, or the other substance we've created is krypton. Okay? So fission, we split uranium into barium and krypton. Okay, we just did that and showed how we figured out that missing one. Okay, let's do another one just in case, just to kind of show you the process. Hopefully we got it down at this point. Okay, so again, we have 1 plus 235, so we have 236 on this side. It's not always going to be 236, but this time it happens to be. If we look here, we got cesium and 3 neutrons there, so we have 143 plus 3, so we have 146, whoops, 146 here. And so my missing amount of mass would be 236 minus 146, or 90. So our missing mass here is 90. Okay? And then same thing on the bottom. We have 92 protons on the bottom over on the left side. On the right side we have 55 and 0, so it'd be 92 minus 55, or 37. So 37 here, and 37 is element, gotta find it here, right here, rubidium, Rb. All right, so that's a fission reaction where we're taking one element and splitting it into 2 new ones. Okay. All right, next is fission, and if you want to try that last one, we can look at that one later. That was fission. Fusion is when you take 2 atoms and combine them together. So you're forcing those 2 things together, and they actually produce a large amount of energy, even more than fission. Okay? And a fission reaction would be like what we have in nuclear power plants. Fusion reactions are like the sun, nuclear explosions from a nuclear bomb, that kind of stuff. All right? So we can do kind of the same thing here with this. Okay? So for this one, we're taking 2 elements, and we're creating 1 element. Okay? So if we do kind of the same process here, this one's pretty simple. If we add up the top here, the top mass is 4. If I look over here, I only have energy, so all the mass is going to come from our missing element here. If I do the bottom ones, 1 plus 1 is 2, so we have 2 there. And element number 2 is helium right here. All right, so I formed a helium atom and some energy. So that's known as a fusion reaction. We're combining 2 things together. All right, let's try this next one just because it's showing a little bit of a particle here. So here, if we do kind of the same thing, we have 4 hydrogens we're cramming together. Okay, so the total mass of this hydrogen on this side, there's 1 for every hydrogen. I have 4 of them. 4 times 1 is 4. Okay, and if I look on the right side, right now I have 4 for my helium. So I'm already at 4 and 4. So I don't really need any mass here for this other one. So that first mass is going to be 0, right? Because I have 4 from there and 4 on this side. The number on the bottom is the number of protons. We have 4. Okay. Right now I have 2. So I need 2 more. Okay. So I'm going to add 2 on this bottom side here. Okay. So plus 1, but I have 2 of them. So I have a total of 2 positives there, 2 protons here, plus 2, which gives me a total of 4. And if you remember, that particle, when you have it look like that, is what we call a positron. So this is a positron. So if you add them up, you have 2 from here, 2 from here, a total of 4. So we end up with 4 total protons on that side and on that side. Okay? So we've created a new substance, and that's fusion. Like I said, that produces a lot of energy. Okay? All right, let's go to the back side here. I'm going to do a couple of these. So induced transmutation is when you have, when we make a new substance. So scientists using particle accelerators can actually crash particles into other elements, particularly their nucleus, and if they can get it to stick, they can actually create new things. So a lot of our bigger elements, as you get past kind of uranium, plutonium, some of those real big ones in the hundreds, those are all synthetically made. They make them in a lab. They don't exist in nature. Okay? But what we do here is we have one element, and we are are creating one new element. So you're actually making a new substance. I can spell it. There we go. Okay? So it's not the 2 to 1 or 1 to 2, it's just 1 to 1, but we're creating a new substance. Okay? Process is still the same. We add up the tops, so the top here would be 18, the bottom would be 9. Okay, and if I look over here, I have 1 hydrogen. So in order to get to 18, I need 17 on the top here. And I have 1 hydrogen proton, and I have 9, so I need 8 on the top here to get me to 9. So 17 plus 1 is 18. 8 plus 1 is 9. So those match up. Okay? And that element is, happening off the top of my head, which is oxygen. Okay? All right, let's do one more of these. We have total on the top here, we have 28. On the bottom, we have 13. Okay? If I look over here, make that little squiggly line. I have 4 here, so this has got to be 24. 24 plus 4 is 28. And then the bottom, we need a total of 13, so I would have 11 here, which again, I know off the top of my head, it's be sodium. Okay? 11 plus 2 equals 13. All right? Okay, so that's the idea behind those. We find the missing element, and we should generally know what those substances are. Okay? All right, so you can also grab this worksheet. The front side of this worksheet you should be able to complete yourself. All right? And I'll have a key up on the front of the board there for us to take a look at. Okay? But I wanted to focus on the back side here and kind of show you what we're doing here. So on the test, we're going to ask that you not only find the missing element, but then tell us what type of a reaction it is. And we've done a bunch. We've done alpha, we've done beta, positron, electron capture, fission, fusion, and induced transmutation. Okay? So yeah, we got a lot. Okay? So let me show you, I'll do a couple examples here. Okay, so for this first one, okay, again, if we think about this, we got 226 on this side. I have 4 here. So this missing element is going to be 222. And on the bottom, we have 88. We have 2 here, so this has to be 86. Okay? And then element number 86 is, top of my head here, radon, right there. So radon. Okay? And if I look, what kind of process is this? Well, I have an alpha particle here, okay? And it just reduced my initial stuff to a new substance. I got my alpha particle. So this would be an alpha decay. All right? Next one, okay, this one's fairly simple. There's nothing on the right side, so I'm just going to add up the top. 1 plus 2 is 3. 1 plus 1 is 2. Element number 2 is helium. And we're combining together 2 elements to make 1. And that's the definition of a fusion reaction. Okay? So what I'm going to have you do is finish up the rest of this. I have the key on the board. Then there's an exit ticket in Schoology for Lesson 8 you can look at and finish that as well, which is basically goes through the same thing. So the goal for the rest of the period is to finish up the worksheet and the exit ticket. See you later, science folks.